Good day, students. Today we are going to look at plane shapes. All right. It's a subtopic under mensuration, and I'm sure you are familiar with this topic, because you must have treated it in your junior secondary school. All right. So we're going to list certain plane shapes that we're going to discuss today. Okay. We're going to list them right now. We talk about circle. Okay, we talk about square, we talk about rectangle, we talk about parallelogram. All right, we talk about triangle, we talk about trapezium, we talk about rhombus, and I think that's all. Okay, and what's our aim in talking about them? We want to know their areas and perimeters. We want to know their areas and perimeters. That's our focus. Okay, their areas and perimeters. All right, so let's start with circle. You should have been aware of this before. Every good knows, a circle. All right, we have something like this. All right, this is a radius. All right, we know the area of a circle is what? Pi r squared, and the perimeter, which we call the perimeter, is what we call the distance round a shape, the distance around the shape. But for circle, we don't call it perimeter, we call it circumference. So the circumference is 2 pi r. All right, why r is the radius. All right, and it's possible you are given diameter. Okay, diameter equals to 2 times r. All right, diameter is a line that divides the circle into two equal halves. Okay, all right, I'm sure this is clear enough. All right, let's go to the next one. Okay, let's go to the next one. Square. We have a square having all sides equal. We have L. Area of a square is L squared. The perimeter of a square, that's the distance, will be 4L. That's as simple as that. Okay, now and then we have a rectangle. Okay, we have the length and we have the breadth. Okay, if the length is here, the length is also here. If the breadth is here, the breadth is also here. The area of a rectangle is length times breadth, while the perimeter of a rectangle is 2 into bracket L plus B. Okay, all right, so let's look at a parallelogram. All right, now the parallelogram looks like this. Okay, something like this. I used to call it a bent rectangle, and we can bring out a height here. Okay, now we call this X. Okay, and we can call this Y. All right, and we can pick an angle here, which we call an alpha. Are you with me? Now the area of a parallelogram is base times height. Okay, which is base times height. So in this case, it is X times H. As the case may be, the base times height. I get what I'm trying to say. The base times height. All right, and another thing that we can call that, apart from that, X times H, is that we can say area of a parallelogram is X times Y sine alpha. x times y sine alpha. Let me show you that again. Let me show you this again. Look at this. The area of a parallelogram, you see that the base times height. Are you with me? Or sometimes if you don't know the height, we will have this value, so it will be x times y times sine of this. Okay? Okay? Alright, so that's about that. And the perimeter of the parallelogram will be 2 into bracket x plus y. Now that's simple. That means we are adding all the sides of the perimeter. Is that clear? We are adding all the sides of the perimeter. Alright, so now let's look at rhombus. Alright, rhombus has all sides equal. Alright, although slants too. Okay, the sides are equal. Alright, but the distinguishing factors are the diagonals. As I said, this is a revision class. The distinguishing factors are the diagonals. Okay. So this we are taking that this z, all right, this z is a smaller diagonal, all right, and y is the longer diagonal. So pay attention. The diagonals of the rhombus, one is longer, and while one is what is shorter. Okay, one is longer and one is shorter. All right, so pay attention to that. So and now please pay attention to this. So we say that the area of a rhombus equals to half times y times z. Half times y times z. Is that clear? Half times y times z. All right, and then the perimeter of the rhombus. The perimeter of the rhombus equals to 4x. Where is the x? We are taking this side as x because they have equal sides, so it's x plus x plus x plus x. So that is the perimeter of the rhombus. So please pay attention to that. Now let's look at a triangle. Okay, now we have a triangle like this that has a base b and that has a height h. Are you with me? So we say area is half times base times height. The area of a triangle is half times base times height. Okay, half times base times height. Now another thing we can look at is assuming we have an angle theta. Are you with me? Assuming we have an angle theta and we have a base, okay, but we do not have height. Let's say we have a side like this. We're given a side like this base and one of the sides. All right, the area will be half times base times c sine theta. So it's half bc sine theta. Half bc sine theta. So the area of a triangle, some of the times it's not fixed. It's dependent on the parameters we are given. Okay, so in a case where you are given the base and the height, the formula to use. In a case where you are given one of the sides and the base and an angle, you know what to do. Okay, now let me give you another formula in case you are not given the base, you are not given the height, or you are just giving the three sides. All right, you are giving the three sides of the triangle. We call it the Eros formula. Now pay attention. Let's assume we have a case where you are given a triangle like this. Okay, you are given a triangle like this. You have side A, you have side B, you have side C. Are you with me? And you are asked to find the area of the triangle. Okay, no height, no angle. All right, in this case, so we use what we call the Eros formula. The Eros formula is that it says area equals to square root of s into bracket s minus a, s minus b, s minus c, something like this. All right, and what is s? S equals to a plus b plus c over 2. So this formula helps you to find the area of any triangle given the three sides. Okay, given the three sides. So that means I've given you three formulas of the triangles. All right, so we've looked at triangles right now. Let's look at trapezium. Let's look at trapezium. All right, trapezium. All right, now the trapezium looks like this. Okay, something like this. We have A, we have B, right? Okay, and we have an height. Okay, we have an height. The area of the trapezium, okay, it will be equals to half into, and these two sides, pay attention, are parallel. These two sides are parallel. So the area will be half times A plus B times height. Okay, the area will be half into bracket A plus B, all right, times height. Is that clear? Is that clear? And what will be the perimeter of the trapezium? Now, if this is A, this is B, and this is C, and this is D, the area of the trapezium will the perimeter of the trapezium, sorry, will simply be adding the three sides, the four sides. So perimeter will be A plus B plus C plus D. Is that clear? So as a recap, we have looked at circle, square, rectangle, parallelogram, triangles, rhombus, and trapezium. All right, so I'm going to send you classwork of shapes, you know, that are of square, triangle, you know, circles and the likes, that I want you to work on, and you know, use the formulas I have given you to find their areas and perimeters. Please ensure you work on that. Okay, have a beautiful day. We see you in the next class.